Hello, and welcome back to another episode of Math Tutor. As always, we are here to support your math learning. Continuing from episode 307, this is Trigonometry 308. If you haven't watched episode 307, click on the link above. Lesser known trigonometric functions. You may need to recall episode 306, Trigonometry extended to any angles, episode 307, Trigonometric graphs, and Set Theory, Unit 1 of the Class 11th text. In this episode, be prepared for a lot of graphs. Here are the graphs for the functions sine, cosine, and tangent. We begin with defining the three functions cosecant, secant, and cotangent. Cosecant x is the reciprocal of sine x. Secant x is the reciprocal of cosine x. And cotangent x is the reciprocal of tangent x. These are results you are aware of from grade 10. Some new conventions make use of CSC for cosecant, but we stick to the NCERT text and make use of the notation cosec. To graph the cosecant function, let's look at the sine function from 0 to pi by 2. The graph of the reciprocal of these outputs are in brown highlight, a part of the cosecant function. As we proceed beyond 0 to pi by 2, notice cosecant approaches infinity when sine approaches 0 and touches the sine curve at the outputs 1 and minus 1. We have the graph of the cosecant function. Notice that the graph has vertical asymptotes at multiples of pi. Clearly, cosecant is not defined at these multiples of pi. Hence, the domain of cosecant includes all real numbers other than multiples of pi. As for the range, notice that there are no outputs between -1 and 1, excluding -1 and 1. Or, that is to say, cosecant covers all reals larger than or equal to 1, all reals less than and equal to -1. To graph the secant function, let's graph the cosine function from 0 to pi by 2. The graph of the reciprocal of these outputs are in brown highlight, a part of the graph of the secant function. As we proceed beyond 0 to pi by 2, notice secant approaches infinity when cosine approaches 0 and touches the cosine curve at the outputs 1 and minus 1. We have the graph of the secant function. Notice that the graph has vertical asymptotes at odd multiples of pi by 2. Secant is not defined at these odd multiples of pi by 2. Hence, the domain of secant includes all real numbers other than odd multiples of pi by 2. As for the range, notice that there are no outputs between -1 and 1, excluding -1 and 1. Or, that is to say, secant covers all reals larger than or equal to 1, all reals less than and equal to -1. To graph the cotangent function, let's start with the graph of the tangent function from 0 to pi by 2. The graph of the reciprocal of these outputs are in brown highlight, a part of the graph of the cotangent function. We can go beyond the interval of 0 to pi by 2. The dotted lines in blue indicate vertical asymptotes of the tangent graph, and the dotted lines in brown indicate vertical asymptotes of the cotangent graph. We have the graph of the cotangent function. Notice that the graph has vertical asymptotes at multiples of pi. Cotangent is not defined at these multiples of pi. Hence, the domain of cotangent includes all real numbers other than multiples of pi. The range, much like the tangent function, covers all real numbers. Based on the graphs of sine, cosine, tangent, cosecant, secant, and cotangent, sketch the graphs of the following trigonometric functions for the given domain and write down its range. Pause the video if you would like to try it yourself. Here are the answers. The dark points are included in the graph. The points in white are excluded from the graph. The dotted lines are asymptotes. The range are given above as intervals. Did you get all of them right? Now to find the function when the graph is known. Describe the following graphs using appropriate trigonometric functions. Pause the video if you would like to try it yourself. Beginning with the first graph, the first piece from minus pi to minus pi by 2, the graph may be described by the sine function. From minus pi by 2 to 0, the graph may be described by the cosecant function. The common point to both the pieces at minus pi by 2 can be accounted for in both the pieces, discounted from the first piece, or accounted in the first piece. Moving on to the second graph. The first piece from minus pi by 2 to minus pi by 4, the graph may be described by the tangent function. From minus pi by 4 to 0, the graph may be described by the cotangent function. The two pieces have a common point at minus pi by 4, which may be accounted for in both the pieces, discounted from the first or discounted from the last. As for the third graph, the first piece from minus pi to minus pi by 2, the graph may be described as a reflection of a part of the cosecant graph about the x-axis. Hence, the outputs in this piece are negative of that obtained by the cosecant function. The second piece from minus pi by 2 to pi by 2 can be viewed as an upward vertical translation of a part of the cosine function. Notice that there is a 1 unit upward translation. Hence, the outputs in this piece are 1 greater than that obtained by the cosine function. The last piece from pi by 2 to pi forms a part of the graph of the cosecant function. As for the fourth graph, the first piece from minus pi by 2 to minus pi by 4 forms a part of the graph of the cotangent function. The second piece from minus pi by 4 to 0 describes a part of the graph of the tangent function. The third piece from 0 to pi by 4 is a reflection of the tangent graph about the x-axis, which implies that the outputs of the piece are negative of the outputs of the tangent function from 0 to pi by 4. The last piece of the graph from pi by 4 to pi by 2 is also a reflection of a known trigonometric curve. You can show that the piece describes the curve minus cotangent x from pi by 4 to pi by 2. Were you able to describe all the graphs? As an open problem, can you design the figure shown using trigonometry? We'd love to hear your ideas on this, so do leave us your comments. If you like the video, don't forget to hit like. If you think it's worth a share, do share. If you wish to stay updated about new videos, do subscribe. Oh, and don't forget to leave us a comment if you want to share your thoughts about the video.